You can solve parts of a right triangle or non-right triangle by using the law of sines or the law of cosines. I'm going to look at the law of sines in this lesson. Now, law of sines can be used in different cases. Angle, angle, side, angle, which as the side is included, and side, side angle where the side is not included. The law of cosines is used in these two cases. So I want to first develop the law of sines by looking at this non-right triangle. And the first thing I'm going to do is drop a height down and write down that the sine of A is equal to h over c, opposite over adjacent, opposite over hypotenuse, and the sine of angle C is equal to h over A. And when I solve both of these for h, I end up with this. And then I want to substitute one right in for my h, since they're both equal, and I can write down c sine A equals A sine C. And I want to divide by A and divide by C, and you're going to see that you end up with the law of sines. Now, this can be in this order, or it could be flipped. So it could be A over sine A equals C over sine C. Either way, you can write it. When it's written like this, you can choose any two ratios and set them equal and solve the problem. Now, the problem with the law of sines is it can have an ambiguous case, meaning that it's unclear what the answer really is. But instead of trying to remember all of this, what you should know is that the answer will always come out in the math if you do it correctly. And sometimes you have to have two cases when you're looking at taking the sine of an angle or the sine inverse of a number to get an angle. So let's do a couple examples and see what I'm looking at. Now, the first thing that I want to do is identify each type of triangle. So this is a side, side, side. That would be law of cosines. Side, side, law of cosines. This is going to be angle, side in that order, and therefore law of sines. Angle, side in that order, and therefore I can use the bottom two and do the law of sines on both of them. I'll just set them up. So to do that, I want to solve for this third side. Now notice that that I'm looking for a side opposite 20, so I can get this side, call it C, and therefore I like to put the C first. C over the sine of 20 is equal to 200 over the sine of 150. You're going opposite pairs, side and angle, sine of the angle, side and the sine of the opposite angle. At this point, you would cross multiply and solve for C, and therefore you could get the third side as well. This would be 180 minus 170 would be 10 degrees, and you could apply the same thing to get that angle. Same thing here, you're looking at what can you solve for. I see that this is a pair, and opposite 45 is your B, so I would say B over the sine of 45 equals 10 over the sine of 30. Again, cross multiply, solve for B, and then you could get your C by finding out what that angle is. Be careful with the ambiguous cases, because the ambiguous cases can get tricky, and when you look for the angle, remember if it's a positive angle, a positive number, you can have two cases for the sine.